Good evening, everyone. I'm Karthik, and I've been part of the engineering business for close to 25 years, and especially leading a team of telecom, enterprise, and I kind of cover both sides of the coin. So I would probably talk about what kind of use cases that we see on the 5G side. I think some of the speakers have already covered a few points, so I would not repeat them. But also, how do you think you need to think about designing systems for 5G? And some of the elements that I would really relate to it is about if you look at the present networks today, what kind of limitations they have. And I don't think Wi-Fi networks can meet the kind of reliability requirements that are required from the industrial IoT standpoint. Similarly, the wireline LAN is too expensive to maintain and for the kind of security and data speeds that are needed. And LTE cannot meet the latency. So these are the current challenges that we see. And how do you think when you are really designing the next gen network, what are the things that probably would create opportunities to be addressed? Because one is based on the current challenges, second is based on the new opportunities. With today's market, a lot of challenges are around broadband speeds, especially the video monitoring and remote monitoring. Now, what is this use case on video remote monitoring? We have seen some of the startups which are working on vision-based systems which can track how the manufacturing process takes place in the line. By just observing the manufacturing process without any feed, it can actually generate a process worksheet or process flow based on what it sees as video that is recording it and trying to annotate it and start coming back and telling you that, you know what, this is the 7-step process your manufacturing is following vis-a-vis what you would have designed for. So you may not know whether it is matching with what you designed for, and you can actually get what it is actually performed for. So this is going to be enabled through video monitoring, and that requires very, very high speed broadbands and data to stay local. I think a lot of challenges that is coming up is to ensure that how to really have large amount of data being stored locally and be able to process locally, and how do you think you can generate the edge analytics. And ultra low latency, I think Uday also talked about it. When I talk about ultra low latency, when you're really having an augmented or virtual reality enabled worker, I think they would really need help real time. And if they're trying to fix an assembly issue, and if they're being helped by an expert from the other side, you cannot have a lag. So it has to be really a real time. And high reliability robotic control. I think we again heard about this from the previous speaker. So when you're talking about industrial robots, which is operating, and the way that the robots would get designed is a lot of intelligence will go to the back end, and the robots in the front end will become a sheer hardware. So it's like a virtualization that has happened in the telecom hardware will happen on the industrial side as well. So you will find the intelligence in terms of if n equal to 1 is what the manufacturing assembly lines are going to be performed. I think a lot of robots will not be purpose-built robots. It will be generic robots which will probably take the requirements that are coming from the back end. So it can actually perform operations for each vehicle that are going to be assembled based on the type of vehicles, based on the type of operations it is required to be done. So that is going to be enabled through some of these controls which are going to be supported with high reliability requirements. Dense deployments for IoT, I think these are essentially what are the requirements for 5G to design and test for. Now, what are the design considerations for 5G? We kind of try to bucketize them in 9 classifications. One, I think it is about network slices. When you talk about 5G, I'm sure the next sentence that you will hear is about the network slicing. And this is going to be enabled with kind of throughput that you need and the latency that you need. And for example, you need a fat slice if you're really trying to do a CCTV offload, which is a heavy bandwidth, which is requiring to feed the data of video to the backend, or a thin slice for a smart meter, which is not going to generate too much of data on a continuous basis. Now, this flexibility is being brought in as part of what we call them as network slicing. The second is about scalable and elastic network. And the example that is talked about here, if you have some events, if there is an IPL match that is going on, how do you think you can actually have, while there is a live match that is going on, people can view at different locations of the stadium how the match would be viewed? Can you really get the same experience sitting in your place? And this is possible with the kind of broadcasting with a scalable and elastic network that is going to happen with 5G. Third is about global roaming. And while this is not just about 5G, it can also perform the same way for 4G. But with eSIM coming in, I think this is going to be enhanced in terms of how you don't need to bring products which are pre-built with SIM, and you can actually have an electronic SIM which can probably be activated depending on the country where you are selling it, whether it is for a robot or whether it is for a car. I think you would be able to really have the connection that can be established based on the place in which it is going to be operationalized rather than place in which it is manufactured. The next one is about 5G private network. I think a lot of them have been talked about earlier as well. I think this is going to be cheaper than wireline, and this is faster than 4G. And this is going to be a way by which all the warehouses, plants, dealerships, I think they all will get connected with high-speed bandwidth. And why is it needed? Who's going to really use this? If you look at over-the-air upgrades on cars, and when you're talking about hundreds of ECUs which are in the cars, which need to be upgraded on a real-time basis, and you want to really have those ECUs with upgraded features, whether it is about advanced driver assist feature or automatic parking feature, and if you're upgrading a software, currently you need to take your car to a Wi-Fi environment and get it upgraded, because it is humanly impossible to do it on a cellular network, even it is 4G LTE. So you need to have this kind of 5G network, or you need to have a private network to really enable your cars to be upgraded with over-the-air upgrades that are required to be done. The next is most important thing relevant for IoT is about the battery life, because you have an opportunity to keep a network sleep cycle. And the biggest challenge that people are still ignoring today, when you are installing those sensors, how long do you think those sensors are going to be alive? What happens if the battery runs out? How do you replace them? When you're talking about billions and billions of sensors, can you really replace one by one? How do you think you can actually extend the battery life? I think 5G will offer the option when you are really not requiring the data to be shared. Can you really put the sensor on a sleep mode? I think this is the significant benefit that you'll start seeing with the 5G network. The next one is about the massive IoT, where you have high density deployments. How do you think you really need to take this into account? Mobile edge compute. This is going to be how do you really catch the content? For example, if there is a match that is happening in Bangalore and you want to really have this broadcasted in your mobile, and if you have a quality of service signed up for, if you're watching this on Hotstar, how do you think I can actually give you a quality of service that you can actually watch it as good as when you're on the ground? So this is going to be done through the mobile edge compute, so which means you're going to have a local cache that will really start giving a booster that is needed, and you can actually get the same quality of service as any other network can provide. And this is going to be extended to various, I'm sure 5G will create new opportunities of gaming that can be played between two players in two different countries enabled through 5G, and this is really going to be a big opportunity on the gaming side. Network exposure for application. This is another new feature that is required for 5G. And what does this mean, and how do you think you can actually have a sensor querying the network? Hey, am I sufficient enough for the kind of surgical operation that I'm supposed to perform, or for the kind of fleet management requirements I have? If I need to have a over-the-air upgrade on my product, can I really ask for a higher bandwidth? Can I actually do it real time? So this is going to happen from sensor, not from the network side. So that is going to be enabled through the network exposure function. Last but not the least is about whether it is standards-based IoT devices. How do you think if you are going to comply to 3GPP, you can actually get them integrated into the product?